Hi, and welcome everyone to our course for solar energy. In this lesson or in this section, we are going to discuss some basic concepts of solar energy. So first, we have a typical PV system, as you can see in this figure. This representing a PV system which is used to provide electrical power to our house, for example. So we have several components in this figure. First, we have the solar panels. Solar panels are used to convert the solar energy or the energy from the sun, okay, into electrical energy. So this solar panels produces DC power, okay. That is the first component of our system. Second component is that we will have the solar charge controller. This regulates the charging voltage of the battery. Now, as you can see in the system, we have solar panels that produces electrical energy. And we have here batteries. What is the function of batteries? Batteries are used to provide electrical power at night or when the sun is not available. Okay. So in order to charge these batteries, we need a charge controller that is responsible for charging this battery. Okay, so we have here DC voltage. Now, as you know that in our house, we use what? We use AC voltage. So as you can see, the power coming from the batteries or the solar panels is DC power, and in our house we need AC power. So in order to convert from DC to AC, we need the inverter. So the inverter converts the DC voltage into AC voltage required for operating our house. Okay, so as you can see in this figure, this is representing a complete PV system, or to be more specific, an off-grid PV system. So we have how many components? We have the solar panels, we have the charge controllers, we have batteries, and we have the inverter. 1, 2, 3, and 4. So we will start discussing in this lesson the solar panels, and then in the next lessons we will discuss the rest of all of these components. So before we start discussing the solar panels, we need to know why should we use solar energy instead of something like wind energy or wave energy. First, it provides green energy. It does not consume or provides CO2. Second advantage is that it is free and available all of the time, or to be more specific, in all of the regions of the world. It can be used locally, which means it reduces losses. What does this mean? It means that I can install it on my own house directly and to provide electrical power to my own house. The fourth advantage is that it is the operation and the maintenance costs of PV system is very low, because all you have to do, or usually what you have to do, is that you need to clean the solar panels every now and then. Also, it is silent. It means it does not have any noise, okay, because it does not have any mechanical parts. As you can see, it has no mechanical parts. It does not move. It does not have any mechanical parts, like for example wind turbines. You know that wind turbines, they are rotating and or contain mechanical parts, which means it affects birds and any flying objects. And of course, it is very easy to install solar energy. And it is also used in the spacecraft applications such as satellites or any missions to Mars, for example. It needs or it is operating using solar energy. Now, what are the different disadvantages of using solar energy? Number one, no power at night or during cloudy or rainy weather. So, for example, at night there is no sun. It means there will be no power coming from solar panels. And that's why we need battery in order to be charged by the solar panels to provide electrical power at night. However, you have to know that batteries are the most expensive part of the whole PV system. It is the primary cause of the high cost of PV systems in general. So it is the highest or the most expensive components of all of these systems. Okay, so this representing a disadvantage of using solar energy. Another thing, it requires additional equipment such as inverters and batteries. It has a low efficiency from 15 to 18%. Usually you will find that monocrystalline, as we will see in this video, type of PV panels called the monocrystalline. It has an efficiency in the market, you will find about 18%. So it is very low efficiency. Okay, it just absorbs from 15 to 18% of the energy of the sun falling on it. So it is in general low efficiency or low conversion of energy of the solar energy into electrical energy. Okay, compared to other types of renewable energy such as wave energy and wind energy. And of course it needs continuous cleaning. And for high power PV requires a large area which is difficult to obtain inside cities. Okay, so depending on the space on your own roof, you will get a certain amount of power. Okay, and to produce gigawatt projects, for example, you will need a large number of panels or large area. Okay, so first let's discuss the construction and principle of operation of a PV panel. So first, this is a PV panel as you can see here. Okay, now this PV panel, as you can see, it is used to convert the energy of the light or solar energy into electrical energy by an effect called the photovoltaic effect. Okay, so before we go to this slide, let's get back here. You will find that this is our panel, okay, which is the one which is available in market. We use several panels. We connect them in series and parallel in order to achieve a certain current or a certain voltage. Okay, you can see that this panel is formed of cells, PV cell. You can see this block is called a cell, this block is called a cell, and another cell, and so on. So we have PV panels, different types of PV panels according to the type of PV cells, as we will see in this lesson. So let's see what is the construction of a PV panel. So a PV panel, as you can see here, consisting of all of these components. We have a frame which is used to mount the solar panels during installation. We have the glass panel here, which is used to protect the solar cells here, okay, from damage. Okay, then we have here two layers here. These two layers are used to protect or hold the cells in position and prevent the moisture and dirt from reaching these cells. Okay, then we have the junction box, which is used to connect the other PV panels with it, or it is used to give us the two terminals of this panel. We will discuss it in details, don't worry, in the next lessons. Okay, so here this is the main construction of a PV panel. Now you can see that here, let's look carefully about this. You will see that we have cells here, solar cells. Okay, so we have each solar panel like this, 1, like this one, or like this one, consisting of a building unit called cell. Okay, each cell is used to convert the solar energy into electrical energy. Okay, then each panel, or sometimes we call it module, okay, can be connected in series and parallel to form something which is called array. Now, why do we connect PV panels in series and parallel? In order to increase the total voltage and total current. Don't worry, we will discuss this also in the next lesson. Okay, so what we need to know is that how does the PV cell converts the sunlight or solar energy into electrical energy. Okay, so if we take just one cell, this graph representing one cell. Okay, now you can see there is the first layer here. We have a coating layer or an anti-reflective layer. This prevents the reflection of sunlight and allows all of the sun or most of the sunlight to pass through it and reaches the solar cell or the inner solar cell. Okay. Now you will find that we have conductors. The conductors here, this conductor and this conductor, is used to give us the two terminals of a cell. Okay, two terminals, positive and negative. You know that any battery, for example, like this, a battery has a positive and a negative terminal. So we have here a metal part, a metal layer for the negative or positive, and other layer for the positive or negative. So we will have a positive terminal and a negative terminal, so that when we connect an electrical bulb or any load, we will have current going from positive to the load, such as a bulb, for example. Okay, a bulb like this, and getting back to the negative. Okay, now the most important part of this PV cell is the PN junction. This part, PN junction is the one which is responsible for the conversion of solar energy into electrical energy. So you'll find that each photovoltaic cell is basically a sandwich made up of two slices of semiconducting material. Photovoltaic cells are usually made of silicon, the same material used in microelectronics. To get this field, or to get an electric field, the manufacturers use or dope silicon with other materials, giving each slice of sandwich a positive or a negative electric charge. So they add phosphorus to the top layer of silicon, which adds an extra electrons, giving with a negative charge to that layer, and another one we add boron, which gives us a positive charge, and this will lead to the presence of an electric field at the junction between the silicon layers. So what does this even mean, all of this? Okay, to make this easier for you, you have to know that first, the photovoltaic are usually made of silicon. So we have two layers, a layer like this and another layer like this. Okay, this layer and this layer is formed of silicon. Okay, formed of silicon. Okay, now the top layer, we add to it, we inject inside it, we inject phosphorus atoms. Now phosphorus starts making bonds with this silicon. So when we inject phosphorus here in the silicon itself, it will start forming bonds with silicon, and you will find that we will have extra free electrons. So we will have here in this layer extra electrons. Okay, this is due to the composition of the phosphorus itself. Okay, so we will have negative electrons. Okay, excess number of electrons. Now when we add or inject boron to the second layer, you will find that we will have extra positive holes. They call it holes, okay, or positive charges or positive holes. So we will have in the end a layer, the top layer called the N-type layer, N-type silicon with negative charges, and a bottom one which is called the P-type or full of positive charges. Okay, now this due to the presence of a large number of positive holes or fewer electrons, then you will have what is called the p-n junction. Since we have a p-type silicon and n-type silicon, so this combine with each other, forming the p-n junction. Okay, so how did we achieve this and this? By adding here phosphorus and by adding here boron. Okay, due to the chemical reactions itself, we will have excess electrons which are not connected to any atoms, and we will have here excess positive holes which are not connected to any atom. So let's see this in animation so that we can understand the idea. Okay, so we have first the p-type material and we have the n-type material. So we have p-type material which has as we said before, has large number of positive ions or not positive ions, to be more specific, holes. We have large number of holes. And the n-type which has excess number of electrons or large number of electrons. Okay, now when we add these two layers together like this, okay, what will happen in this case? You will find that here, since we have here holes and we have here electrons, okay, so we have here holes and we have or positive holes and we have negative electron. So what will happen in this case? The electrons will start going from here and fill these holes. Okay, the electron want to fill these holes like this. Okay, so when these electrons leave this part and go and fill these holes, what will happen in this case? We will have here positive ions. Okay, and since this electrons goes here, we will have negative ions. So you will find that we will have in the end a positive ion and a negative ion, okay, which will form something which is called the depletion region, okay, which is which has a positive ions and negative ions, as you can see here, due to the chemical reactions between this part here. Okay, so as you can see, we will have p-n junction, positive ions, negative ions, then an electric field will be formed going from positive to negative. Okay, like this. Okay, so here this electric field will help us understand what happens exactly. Okay, so let's look at this image. Okay, so you will see that here we have the n-type material, we have the p-type material, and then when we connect them together, when we put them above each other, you will find that the phenomena will happen. Okay, the electrons, here we have excess number of electrons, negative, 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 and we have here excess number of holes. Okay, at this point, at this intersection point. Now the electrons will go and fill these holes, leaving behind it positive ions. Okay, leaving behind him positive ions, and here will be negative ions. Okay, now this is this is at normal state, without any photons, without any light, without anything, just by adding an n-type over a p-type silicon layers. Okay, now you will find that here what will happen when light comes here and fall on this region or on the depletion region. So when a light will fall on the depletion region, what will happen in this case? the electrons will have enough energy. So when a photon of sunlight knocks an electron free, it gives it enough energy to leave the atom. Okay, the electric field itself will push that electron out of the silicon junction. So you will see that here, when the light falls here, we have a free electron and we have a free positive holes. Okay, now you can see we have a magnetic field, not magnetic, electric field here, from positive ions to negative ions. Okay, so what will happen is that the negative electrons will be affected by the electric field and goes to the place or the location of the positive sign, and the positive holes will go to the negative ions. So you'll find that in the end, you will find that the electrons will go to the upper layer, which is the n-type layer, and the holes here will go to the lower layer. So what will happen when we have lots of light falling, lots of light? So we'll find that when we have large amount of photons, electrons will have enough energy and we will have larger number of holes. So these holes will go here and electrons will go here. So in this n-type we will have large number of electrons, and for the p-type we will have large number of holes. Okay, so there will be large potential difference between these two layers. Okay, so what if we connect this part or the n-type with a load such as a bulb and then connect it to the other layer here? What will happen, do you think? Here we have large holes, okay, large number of holes, and here we have large number of negative electrons. So these electrons would like to go and fill these holes. So they will go through the wire like this and go fill this hole. Second electron will go and fill this hole. Electron goes and fills this hole. So what will happen when we have a flow of electrons? Flow of electrons means that we will have electrical current or electric current. Okay, so I hope the idea is clear. Simply, when we have electrons, when we have energy, then due to the presence of electric field, electrons will accumulate on the n-type silicon layer, and the holes will accumulate on the p-type silicon layer. So we will have here large number of holes, we have here large number of electrons, and when we connect these two layers together, electrons will go to the holes. Why does the electron would like to go to the holes? Because it would like to be in a balanced state, or would like to be in a neutral state. Everything in nature would like to be in neutral state. Okay, so this is how a PV cell works. Okay, now if you look at each cell here, you will find that each cell, this cell will look like this. Okay, or each block like this of the PV panel will look like this. This representing one cell. You'll find that we will have these lines. What does this represent? Called fingers. And we will have two big lines called the bus bars. So the fingers or the bus bars first are used to conduct DC power generated by cell when photons hit the cells. So they are the wires that connect each cell to the other one, allowing the current to flow. So as you can see here in this, where exactly here, if you look here, don't worry, we will see this in the next slide. You can see this cell have a line here, which is a bus bar and another bus bar. Okay, you can see the next cell, it's connected to it in series like this, connected like this, and the next one connected like this, like this, like this, like this. So when the current will go through all of these bus bars. Okay, so they are connected in series and parallel, as we will see. Okay,